Ciao friends and welcome to a new video from SQL BI. I'm Alberto Ferrari and I'm a business intelligence consultant and a DAX trainer. I spend most of my time teaching DAX to different students all around the world. In this video, I want to show you a beginner guide to DAX through examples. When you are a newbie in DAX, you search for examples on the web because you have the idea that by looking at a lot of examples, you can increase your knowledge about DAX and learn the details that are needed to solve your scenarios. The thing is, the kind of examples that you can understand at the beginning, they are simple examples. So there will be just one simple DAX expression that contains one or two formulas that solve a specific problem. And you might derive the wrong idea that learning DAX means learning the details about all the functions in DAX, as if there always were a function to solve your specific problem. The real world is quite different. Most of the times, your specific scenario requires combining together different functions in complex DAX code so that your unique question is actually answered. In order to build this DAX code, you need to learn theory first and understand it well. I want to show this with an example. Therefore, what we will do in this video is not just looking at different functions and how they work. That would be too simple and in some way misleading. Instead, I want to build with you quite a complex dashboard that requires calculation for which we do not have any specific function in DAX. We will need to build the code. And I will keep the theory to a minimum. Nonetheless, let's start by looking together at the final result we want to obtain. Then we reason a bit on top of the entire video, and then we start writing DAX code. We are going to work with the Contoso model. Let's start by quickly looking at the model. Okay, this is the data model we have. Contoso sells goods all around the world, and the sales are stored in the sales table. You can buy your goods in a store. We have different stores all around the planet, and we also sell online. And of course, sales happen to customers. There are also other tables like date and products, but we are not interested in those tables for now. The most important thing are store and sales for now. If you buy in an online store, if you buy in a physical store, then what happens is that you enter the store, grab your goods, pay for them, and you are happy. Therefore, the delivery of the good is the same as the order date. They will happen at the same moment. But if you buy in an online store, then you place your order and it takes some time to deliver this good. Therefore, we have in the sales table two dates, which are the most relevant dates for this demo, which are the order date and the delivery date. This first order has been placed on the 22nd of February, but it was delivered on the 25th of February. Therefore, it took 3 days to deliver the order. And we want to do an analysis of how good we are in delivering orders in different countries all around the planet. So the final dashboard that we are going to build is this one, that shows the cumulative percentage of delivered orders by the number of delivery days. Let me show you the details about the dashboard. Okay. We have on the columns the number of days required to deliver an order. 1 day, 2 days, 3 days, 5 days. Then we have the different countries where we ship our orders. And here, the first cell, 16.53%, means that 16.53% of the total number of orders has been shipped in 1 day only. Then we have 39.67%. This is a cumulative percentage, meaning that this number, 39.67%, includes the orders shipped in 1 day and 2 days, and the number always grows. So here for 7, that says that 95.59% of the orders in Australia have been shipped in at most 7 days. Then, when we reach 100%, we know that all the orders have been shipped in at most 10 days. The dashboard also needs to color the cells. You see that we have some cells that are colored in blue, some others that are colored in red. And the reason for this is because we compare each cell with the global percentage. The blue cells are above the global percentage, whereas the red cells are below. 12.90 is below 14.95. So we want to provide a visual color, a visual information to the user that quickly shows whether in a specific country we are better or worse than the average. Finally, talking about the dashboard, you see that when we reach 100%, we stop showing further values. Once we have reached 100% for 7 days in Germany, Italy, and the Netherlands, we do not show further values. That makes it easier to focus on the numbers where they are relevant. Building the dashboards will require some work. We will need to first compute the number of days which are required in order to deliver an order. Then we will need to slice, compute the percentage of orders delivered in different days, and finally color the dashboard the right way. There's a lot of work to do. And as you might guess, there are no DAX functions that will help us with a single line of DAX code. We will need to write it together. I will keep the theory to a minimum, the minimum required in order to understand the code that we are writing. With that said, I will explain some theory, because the basic theory of the row context, the filter context, and the calculate functions are required in order to understand what we are doing. Nonetheless, nearly the end of the video, I will show you that the code we wrote actually contains a small glitch, and fixing that small glitch requires a lot more knowledge. It's just a single line that needs to be changed, but you need to know that. And to know that, you need theory. So the goal of the video is to show you how to write complex DAX code, how to combine together simple functions, how to understand the basic theory, and hopefully that will raise your curiosity to learn more about DAX. If that is the case, well, guess what? We do have trainings. We have the Introducing DAX training, which is free, and you can find it at sqlbi.com. And if you want to go further, you can learn with the Mastering DAX training that will actually transform you into a guru. Nonetheless, let's start by reasoning on top of the code that we need to write. As we said, we need to compute the number of days which are required to deliver an order. And if we look at the orders table, we have these two columns. We have the order date and the delivery date. The number of days which are required in order to deliver an order is just the difference between the delivery date and the order date. In DAX, you can compute the difference between two dates by just subtracting one day from the other. So we can create a calculated column that subtracts from the delivery date the order date, and that produces the number of days required to deliver the order. So we can do that by simply creating in the sales table a new column. We call it delivery days. First, the name of the column, and then the expression we want to compute, which is the delivery date minus the order date. As I said, just the subtraction of two columns produces the number of days. Unfortunately, the result is not really perfect. You see that delivery days shows a date, it's not a number. And the reason is one date minus another date produces a date. If we want to transform that into a number, we need to cast it using the int function. If I transform that into int of sales delivery date minus sales order date, now this produces the number that I want to see. 3 days, 4 days, 1 day, 2 days, and so on. Right now, this is a column, and a column can be used directly in a report in order to show its value, its aggregate. Let's do that. Now that we have the delivery date, we can go here in the country, in the report that is slicing by customer country. In sales, we have the delivery days. I just drop it here, and you see it shows delivery dates, but the number looks wrong. It's not actually wrong, it's the sum of delivery days, because by default, the engine will aggregate a column, a numeric column, by using sum. We are not interested in the sum. We want maybe the average of delivery days, because that makes a lot more sense. You can do that through the user interface. So I can go here under delivery dates, and instead of showing the sum, I can use the average. So I just click on average, and this is now showing me the average of the delivery days. Now, before moving further, one important detail. You see that we created a column. That column contained 2, 1, 4, whatever number of days required. But when we project the column in a matrix, it always shows the aggregate value. It does not show the value of the column. It can be the sum by default, it can be the average, or whatever you might want. But the value shown in the matrix are always aggregate values. They are not the columns that you actually computed. The columns, the calculated columns, are stored in the model and then used to build the aggregate. Let's focus a bit more about the details of the number. This number, 1.74, is a bit too small. I know the model, and I know that we are not that good. We are not able to deliver in 1.70 days on average our orders. The reason is, as I said earlier, we have physical stores and we have the online store. And the difference that the delivery days make sense only for the online store. For physical stores, this value will always be 0. But right now, if I just compute the average, I average also all the orders with 0 delivery days, combining them together. Right now, I'm slicing by customer country, but in order to understand it better, instead of using the customer country, we can use the store country on the rows. And you see that for all the countries it shows 0. Now this is the store country, except for the online store, where it shows 2.95, which is a much more meaningful number. I want my measure to compute 2.95. I do not want 1.70, because 1.70 is just wrong. So what I could do is add a filter to the report that shows only the sales for the online store. The problem of adding the filter to the report is that you always need to remember to add the filter. And if a user just places the measure or places the calculation in a report without remembering about the filter for online store, the numbers will be wrong. That is why the calculated column was a good option. But it would be better if we build a calculation that automatically includes the filter. So the user will just drag the measure in the report and the number will always be correct. To do that, we cannot just use a calculated column. We need to write a measure. A measure is an aggregation, a calculation that works at the aggregate level. It does not work row by row as calculated columns do. And it is able to we will be able in the measure to add filters and modify the logic of the calculation. So let's start writing the measure. And we started by taking the code of delivery days, which is here. Let me just copy the code. And we build a new measure that already aggregates the average. So we call it average delivery days. Now, if I write the same expression that I was using before for the column, you see that I have an error. The error says cannot find the name delivery date, both for delivery date and for order date. So I have two errors with just a simple expression. What is the reason for that? In order to understand it, we need to introduce the concept of the row context. So let me get rid of this measure for now, and let me explain how a calculated column works. When you write an expression like this, sales delivery date minus sales order date in a calculated column, what the engine does is it computes the column row by row. So it starts on the first row, it computes the value, then it goes on the second row, it computes the value, and it stores those values in the table. But the relevant point is that the calculation happens row by row. Technically, we say that there is a row context. The engine knows in which row it is while computing the values. Therefore, if we look at the data here, because our expression is using order date and delivery date, the engine will start on the first row here. It grabs the value of the order date, the delivery date, subtract one from the other, computes the result, and store it. In other words, the engine always knows in which row it is while computing the values. That is the presence of a row context. In a measure, things are different. A measure is not computed row by row. A measure is computed at the aggregate level, where there are a lot of rows that needs to be aggregated together. Therefore, the expression sales delivery date does not have a value. The engine does not know which row to use to compute the value of the delivery date column. In a measure, you always need to use either aggregations or you need to introduce a row context by starting manually an iteration. Let me show you this. So we have the code, the measure, we have the column. We can go back and write the measure, now knowing that it will not work with just a simple code. So again, right-click, new measure, average delivery days. As we said, we cannot write sales delivery date minus sales order date because the engine does not know which row to use to provide the value for delivery date and order date. But we can introduce a row context by starting an iteration. So instead of just writing the difference this way, we can do an average x of the expression over sales of the expression that we wrote earlier. Now, average x introduces an iteration. The engine, because of average x, will start scanning the sales table and compute the expression that we provide as the second argument of average x row by row. Therefore, here we do have a row context. So this expression is computed inside a row context. And now you see we no longer have any error. I can hit enter, format it as a decimal number with 2 decimal places, place it here, and you see that now my average delivery days computes the same value as the average delivery days. So I just rewrote the code as a measure. We still need to add the filtering part. But while we are here, because we created the average delivery days measure, we actually no longer need the average of delivery days calculated column. Keep in mind that calculated columns are good and you can use them in your data model, but they increase the size of the model. Every calculated column uses space in your model. Therefore, even though for newbies it's good to use calculated columns, when you learn more DAX, you also learn that using measures is a best practice. So try to build all of your calculations with measures instead of using calculated column, because that produces a smaller model and several times also a faster one. So let's get rid of the calculated column that is here, delivery days. We just remove it from, not rename, but remove from the model. Okay. And now we have our average delivery days. As I said, we still need to introduce the filtering. Now, average x introduced an iteration and it is iterating over sales. Let's go to our calculation, it's iterating over sales. So it's scanning the entire sales table. We want to remove from the sales table the orders which are not happening online. And information about where the order happened is in the store table. There is a function that we can use here, which is filter. We filter sales, and here I would like to write where store name equals online store. But again, I have a problem. You see that it says that it cannot find the store, it cannot find the name, even though in store we do have the name, but it doesn't find it. Why that? The reason is filter is an iterator. Again, it is creating a row context over the sales table. Sales does not contain the store name. The row context, the iteration, is happening on the sales table. Store is a different table, and we do not have a row context there. Therefore, if we want to access the store of the current sales, we cannot just write store name. We need to use the related function. Related starts from the current row context and lets you access columns in tables that have a relationship with the current row in the current row context. It is enough to go here and say filter sales where related store name equals online store. And now you see the problem goes away. I can now hit enter, and you see that the average delivery days appears only for the online store. Now, right now I'm slicing by the store name. Remember that we were slicing by country, by customer country. So let's get rid of the store country, and we placed instead the customer country on the rows. Now, this number, average of delivery days, is the correct value only considering the sales that happened online. Using filter is good, and filter is a function that filters and iterators, they are functions that are very frequently used at the beginning. But what we can do is compute the same value not using the row context and the related function, but instead relying on the filter context. Let me explain first what the filter context is. That is the second important topic about DAX. Whenever you write a calculation, that calculation always happens inside a filter. This filter is created typically by Power BI, by the report, by the client tool that you use to build your calculation. Let me show you that with the code here. My measure average delivery days iterates over the sales table. But you see that depending on what country I placed in the report, I have different values, 291, 299, 289. The reason why I have different values is because the calculation happens on different subsets of the data. Even though my code does not say that it's working on a subset of the data, still, the filter created by the report filters the entire calculation. So when I write filter over sales, this sales reference does not reference all the rows in sales, but only the rows that are visible given the filter that the report has placed. So for Germany, this will be the Germany sales. For Italy, there will be the Italian sales. For United Kingdom, there will be the sales in UK. The filter context is a filter that is created by the report, and it affects all the calculations. Now, Power BI, through a matrix or through a report, can create the filter context, so the context under which your code is being computed. But you also have the option of creating the filter context by yourself using the calculate function. Calculate lets you change the filter context by introducing new filters. So instead of writing average X over filter sales, what I could do is get rid of this filter, iterate over sales, take this code, and embed everything inside calculate. What calculate will do, it will create a filter context where only online sales are visible. I just copy the code of the filter. And one good thing about Calculate is that you no longer need related, because Calculate works with the filter context, not with the row context. So I can just write store name equal online store, and that's it. Now my average X iterates over sales, but this is a reference to sales that happens in a filter context that contains a filter for online store. Therefore, writing the code this way produces the very same number. It is a better practice. Whenever you can use Calculate, it's quite always better to use Calculate, because filter removes rows from a table, so it needs to scan a table and get rid of rows, whereas Calculate applies the filters first. It's not actually correct. I mean, the optimizer does a great job in making both filter and Calculate work at a decent speed. But with that said, whenever you can use Calculate to write your code, it is actually a bit better. Now, we have our calculation that is showing a good number, the average delivery days. The thing is, this number is still wrong. It's not correct. Even though it's closer to the correct number, it is not indeed the correct value. Why that? Well, the reason is I'm iterating over sales, so my calculation is averaging row by row over the sales table. But the sales table does not contain one row per order. It contains one row per order line. A single order will have a lot of lines, and my average is averaging individual lines. Let me show you this with the data. If I go to the data view and I sort it by ascending by order number, you see that the first order, 269,500, contains several lines, 1, 2, 3, 4, 5 lines. And for 5 times I have the order date and the delivery date. Now, average X will iterate line by line and compute the difference between order date and delivery date for each individual line. Therefore, an order with a lot of lines will have a much larger weight than an order with just one line, because I'm averaging individual lines. It would be way better if I were able to compute the average at the order level. The thing is, I cannot, because my model does not contain data at the order granularity. It contains data at the order line granularity. What I can do is, instead of iterating over sales, iterate over another table that has the correct granularity, that is, the order. I could create the table this way, a physical table in the model at the order level, only for the sake of this calculation. Or what I can do, and it would be better, is aggregate the values just before iterating over them. So create a sort of temporary table that contains the order number and the columns that are needed to do my calculation. We do have a function in DAX that performs grouping, and it is summarize. Summarize can scan a table and group it by a set of columns that you provide. So I will not need to create a physical table. Instead, I will just build a temporary table on the fly, iterate on top of it, and compute my values. Let's do that together. Instead of iterating over sales, I will iterate over a grouped version of sales, and I use summarize. I can summarize sales by sales order number. Now, summarize returns all the distinct values of the order number in the sales table. But you see, I still have a problem. If I iterate over summarize sales by order number, I can no longer access to delivery date and order date. Why that? Again, it's the row context. Now that I'm iterating over a table that is grouped to contain only the order number, I no longer have access to either the delivery date or the order date. What I need to do is group by not only the order number, but by order number, delivery date, and order date, so that the resulting table contains 3 columns and I can do calculations on top of that. Therefore, what I need to do is summarize by sales order number, sales order date, and sales delivery date. If I summarize over the 3 columns, now you see that IntelliSense does no longer provide an error because the table returned by summarize contains the order number, the order date, and the delivery date. If I hit enter, you see that the numbers below changed and now they have a different value. Now, this technique, grouping, works as long as it is guaranteed that each order has only one order date and one delivery date. If it happens for whatever reason that for the same order number I have different order dates or different delivery dates, then my aggregation would be wrong and I would need to work a lot more. We can check that. We can look at the result of summarize and check whether there is only one row per order, meaning that the combinations of order date, delivery date, and order number is unique. So we can just take the code of summarize and create a calculated table. Let me copy this code. We go here to look at the result and we create a new table. It's just a temporary table for the sake of testing. So test equals my code. Besides, this is also a useful technique whenever you want to check results in a very quick way. And you see that the result is a table that contains the order number, the order date, and the delivery date. Exactly what I was expecting. But how many rows are there? If we look at the number, we have here we have 5,819 rows. So this is the number of rows in the resulting table of summarize. How many values do we have in the order number? Again, we can check that by looking at sales. Just click on order number. And we have 508. Okay, here it is. 5,819 distinct values. This means that the result of summarize has the same number of rows as the number of orders we have in the model. Therefore, our calculation is safe. Each order has only one order date and one delivery date. Now that we check that, we can get rid of the test table that was useful only to compute that number. So let's get rid of it. Now we have our calculation average delivery dates that computes the correct value. Therefore, the first step is completed. We are now able to compute the number of delivery days and slice it by country. But you need to remember that that was not our final goal. Let me show you again the final result. What we want to compute is the percentage of orders delivered in 1 day, 2 days, 3 days, and so on. So we need to be able to slice by the number of days and then compute this percentage. We can start working on this, for example, by looking at the distribution of orders, of the number of orders, slicing it by the number of delivery days. So what I could do is create a new, let me do that on a new page. Instead of slicing by country, I might want to slice by the number of delivery days. And now I'm a bit in trouble because we deleted the column that contains the number of days to deliver an order. The thing is, if you want to compute some value, some aggregated value, then measures are good. But if you want to slice or dice or filter by values, then measures are not the best tool. You cannot use a measure and place it on the rows or on the columns of a pivot table. You need a column to do that. So we need to reintroduce our delivery days column. That's not hard. We just create a new column It was delivery days, which we know is the integer part of delivery date minus order date. Now that we have it as a column, I can remove the country, place the number of delivery days on the rows, and now I have the delivery days and average delivery days, which is not the number that I want. What I want is the number of orders delivered in one day. To compute the number of orders, I can compute the distinct count of the order number. I cannot just use a count rows of sales because that will compute the number of transactions. I need to compute the distinct count of the order number. And we also need to remember that I always need to restrict the calculation to online sales. So to sales that happen in the online store. So we can create our measure. Let's call it number of orders. It will be a distinct count of the sales order number. And I need to add the filter for the store. So we add calculate distinct count where the store name equal online store. And now that I have my number of orders, I can place it in the report, and it shows the number of orders that happen in different with different delivery dates. I can get rid of average delivery days and, for example, shows that as a column chart that shows that the majority of our orders are shipped in 2 days, then in 3 days a bit less, 4 days again a bit less, then 1 day, and so on. So we have all the different values with a distribution. We needed a calculated column because we wanted to slice by the column. But if you remember what we wanted, we do not want to have just the number of orders. We want the percentage of orders against the percentage of orders delivered in one period against the total number of orders. So let's change our calculation. We keep number of orders. Let me go back to a matrix so we can see the numbers. I have the number of orders. I need the total number of orders, and then I need to divide one by the other. So number of orders computes the value keeping the filter for delivery days, and I want to have the total number of orders. So we can create a new measure which is similar to this one. Therefore, I copy the code of this measure and I build a new one that I call number of all orders. That computes the distinct count of sales order number, where the store name is online store, and I need to get rid of the filter from the delivery days. So I need to do a remove filters of the delivery days. This computes the grand total of all the orders, that is 3351. I can place this measure here, and it shows 3351 everywhere. Now it's a matter of dividing the number of orders by the number of all orders. So I can create a third measure that computes the number, now the percentage of orders, which just divide the number of orders by the number of all orders. And this needs to be formatted as a percentage. I can get rid of number of all orders, take my percentage, place it here, and now this shows that in 1 day I sell 14.95% of the orders. In 2 days, 26.69. In 3 days, 25.90. So I have created the measure that computes the percentage of all orders that are shipped in 1 day, 2 days, 3 days, and so on. I need to do a step further. because what I want to have is not the number of orders sliced in this way by the delivery date. I want to slice it by country. So now that I have my measure, percentage of orders, I can go back here, take my percentage, where is it, and place it here. But that shows always 100% because I'm no longer slicing by the number of orders. And remember, if we look at the final report that we have, we want to have the percentage of orders shipped in 1 day, 1 and 2 days, 1 and 3 days, from 1 to 5 days. So that needs to be a cumulative percentage. In order to compute the cumulative percentage, I need to apply a filter to the filter context that says, well, the number of delivery dates needs to be less or equal the boundary that I defined. So I can again use calculate to create another measure that computes, for example, the number of orders that have been shipped in at most 3 days or in at most 7 days by using again calculate. So what we can do is create a new measure. Let's call it percentage 7 days. That uses calculate the percentage of orders, and we apply a filter to the delivery days. Delivery days less or equal, I don't remember the number, 7. This computes the percentage of orders that have been shipped in at most 7 days. We can place that in the report, format it as a percentage, and you see that it shows 99.59%, 99.23%. This is the percentage of order delivered in at most 7 days. And if I want 3 days, I can do a similar calculation. Go here, build a new measure where I just copy the code, and I do the percentage, for example, for 3 days. Now my percentage 3 days computes, formatted the proper way, the percentage of 3 days. I can also sort them the right way, get rid of this percentage, and now my report starts to have a slightly better shape because I do have the country, the customer country, the average delivery days that is no longer useful, so we can get rid of it. And I have the percentage over 3 days, the percentage over 7 days. But let's go back to the result that we want to obtain. You see that we have by country, the number of days is on the column, and this number is unequally distributed, 1, 2, 3, 5, 7, 10, 15. Whereas if I look at the report I have so far, I have measured here, percentage for 3 days, for 7 days. It is true, you could create one measure for each number that you want to show in the report, but that is not really elegant. It would be better if we created a table that contains the number of days that we want to add on the columns, and then we use that information in order to drive the calculation of our measure. So our measure will not use 3, 5, 7 as a fixed number that drives the maximum number of delivery days, but it will derive this information from another table that we create in the model. So what we need is a table that contains our numbers 1, 2, 3, 5, 7, 9, 10, and so on. The best way or the easiest way to create such a table would be that of using a parameter table. You can create a parameter table using Power BI, and that generates a table and builds some measures for you. But the drawback is that the parameter table does not give you the freedom of choosing whatever sequence of numbers you want. Let me show you that. You can go here in modeling, create a new parameter. You can provide the name, the data type, but then you have to provide the minimum, the maximum, and the step. If I want to create 1, 2, 5, then I cannot, because a parameter will be 1, 2, 3, 4, 5 with a step of 1. But we have DAX, so we can create the table on the fly by just building a constant table by including numbers in curly braces. So instead of creating that with a parameter, I build the table as a calculated table. So we go for new table. Let's call this table days. And I can use curly braces. The numbers that I want are 1, 2, 3, 5, 7, 10, and 15. This generates a table with the numbers that I provided. Let me look at the result here in the data view. And you see that we have our table containing all the different values, 1, 2, 3, 5, 7, 10, 15. The column is named value, which is not really a cool name. I want to rename the column. I could do it from here by just choosing the rename feature, or I can use select columns, because it is true I could use rename, but I mean we are learning DAX, and there is a specific DAX function that you can use to rename columns in a table or to reduce the number of columns in a table. And this function is select columns. You use select columns, you pass to it a table, and then you choose the columns that you want out of the original table, plus you have the option of renaming them. So we can simply go here and we use select columns. Out of this table, we want a new column that we call days, and its expression is value. Let me get rid of that. So select columns. Out of this table, I take the column named value, that is the column name that has been chosen by default by the constant table, and I rename it as days. The result of this table is now a table that contains one column days with the values that I want. Now, what I can do is place this column on the columns of my matrix and then use the information. Because if I just place the column on the columns of the matrix, let me get rid of percentage 7 days. So we have only one value, and from the days, I grab number of days and place that on the column. You see that that shows the same number everywhere, because my code is not using the information stored in the days table. It's just using the fixed value 7, 3, or whatever was the number in that measure. The next step is to grab that value and use it in my code. So I have my percentage 3 days. Let me copy the code. I can create a new measure, and the new measure will be percentage x days, where x is whatever value we placed on the columns. Instead of 3, I need to use the value that is present on the columns. And here I have another problem. I cannot write here days, days. The reason is always the same. We do not have a row context that provides a value to the days column in the days table. We should have an iteration in order to have a row context. And here, for this code, an iteration does not make a lot of sense. Nonetheless, there is a function that lets you grab the currently selected value in a table if that table has only one value visible in the current filter context. This function is named selectedValue and lets you grab the individual value present in the filter context if there is only one. So what I can do is create a variable. Let's call it x days, where I use a selected value. Selected value of days. Then we store in another variable our calculation, return result. I'm missing a parenthesis here. And then now that I have X days in my variable, I can use it here instead of the fixed value 3. Now, this code is going to compute the percentage taking the value for the upper boundary from the columns or for whatever I used in order to filter only the given number of days. That needs to be formatted as a percentage. Then we removed percentage 3 days and we place percentage X days. Now you see this is way better. Let me find some space so we see both the code and the result at the same time. Now this is telling me that I have 16.53% of orders shipped in 1 day, 39.67 in 2 days or 1 or 2 days, and so on. So now my percentage over X days is computing the number that I want, the cumulative percentage of order shipped in at most the given number of days, where I can configure the number of days, so the values that appear on the column. If I'm satisfied with those numbers, I'm happy. If I want to change them, it's enough to change the content of the table that I placed on the column, the days table, and that will drive the calculation the right way. Still, I have a couple of issues that I need to solve. First of all, you see that I'm showing 100% here, and I'm showing 100% here. If you remember what we had in the result, let's take a look at that. We do not want to see 100% everywhere. We want to see 100% only when we reach 100% for the first time. Then we want to blank out the measure. We can add further logic. For example, I can go here and say, well, do not return the result if it is above 100% or if it is 100%. If I do that, I can check if result greater or equal to 1. Remember that 1 means 100%. Actually, if the result is less than 1, then return the result. Otherwise, return a blank. The thing is, if I hit enter now, you see that all the values of 100% disappear. And that is not what we want to obtain. We do not want to remove 100% everywhere, which is what this code is doing. What we want to do is slightly different. We want to show 100% the first time and never again for the larger values. Therefore, what we can do is check whether 100% was already reached before. If I'm showing 5 days, I can ask, well, check if in 4 days we reached 100%. And if that is the case, do not show the value because we already shown that for 4. So I need to check if in the previous value we reached 100%. We can do that. We have our result. We can create a new variable. Let's call it check or result. No, let's call it previous result, where I compute this calculation, but I use X days minus 1, the previous value. And then I do not check result, but I check if the previous result is less than 1, then show the result. But if it happens that the previous result is 100% or above, if that were possible, then hide the value. If I hit enter, now you see that something good is starting to happen, even though we are not still perfect. Because we see 100% here, but we do not see it. I need a bit more real estate. Okay, we do not see it here. We only see there for 7. And that's the only 100% that we see everywhere. Now, why is that? The code, now it's time to look at the code a bit better, checks x days with x days minus 1. Meaning that here, in the column 7, it will check it against 6. The column with 10 will check it against 9. But maybe 100% was not reached in 9, it was reached before, or it was reached at a different point in time. We cannot check with the previous value. Otherwise, we do not show 10 because we reach it at 9, but we are not showing 9 anywhere. Therefore, when we are showing the column for 10, we need to check it against 7, because my table contains a jump from 7 to 10. Let me show you that by enlarging the table, because it helps in understanding the problem. Let's go on the days table and we add all the gaps between 7 and 10. 8, 9. Okay, 8, 9, 10, 15. If I now hit enter, you see that I show 100% on 8. I do not show it for 9 and 10. The problem is when my code makes the calculation for 10, it will not show the value because it has already been reached at 9 and it has already been reached at 8. But the thing is, I'm not showing 8. I'm just showing 7 and then 10. So what I need to do is make sure that when I'm computing the value for 10, I check if at 7 I already shown 100%. I ignore 8 and 9, and if I didn't show the value for 7, I show 100% for 10. That requires a bit more work. Let's get rid of 8 and 10, so we go back to the problem, the dashboard that shows the error, and then we fix it. My previous result is using x days minus 1. We cannot use x days minus 1. We need to use the previous value that was present on the columns. And how do I compute that? Well, when I'm here in the column for 10, the previous value is 7. And how can I compute 7? 7 is the maximum values in the days table that happens to be strictly less than the current value. So for 10, the maximum value before 10 will be 7. That way I can compute the previous visible value. That is a different value than just the previous value. Therefore, I need another variable. Let's go on the code. And I compute the previous value. I use calculate. Well, let's start with max. I take the maximum of days, and then I need to restrict this calculation to say I want the maximum days where days is strictly less than x days. Now my previous value, actually I can compute previous x days just to be consistent with the name. So this is now the previous value, that is 7 in the case of 10, and I use previous x days here instead of x days minus 1. By doing that, now with this code, you see that the numbers are computed correctly. I show 99.59% for 7, and then I jump on 100% to 10. I don't know when between 7 and 10 that value has been reached, the value 100%, but depending on how I build my table that I place on the columns, I will obtain the correct result. And we blanked out all the values after I reach 100% for the first time. So you have seen so far we have been able to create the entire calculation by combining different pieces of DAX code. Still, if we look at the final dashboard, the final dashboard contains nearly the same values, but it is also colored. So we need to go for the next step that is color the right way my my dashboard. So I need to understand when my percentage is above or below the overall percentage. Therefore, I need to compute the percentage for the current selection and the percentage for overall time. And then I compare the two. And I will build a measure that returns 1 if I want the cell to be green or blue, and -1 if I want the cell to be red. And I will use this measure in the conditional formatting feature of Power BI in order to color the background of my cells the right way. Therefore, I need a measure that returns -1 or +1 depending on the relationship between the value of the percentage for the current selection and the value of the percentage over all time, all products, all countries, and so on. So I can create another measure. Let's call it previous. No, it's percentage PCT, percentage X days color. I need first the current value. So I store it in a variable, current value, which is a percentage over X days. Then I need the total value, the value of all orders. Let's call it total value. How do I compute the total value? The total value is here, 14.94%. In order to compute this value, what I need to do is get rid of the filter that happens to be on the country. So I have a filter on country. If I get rid of that, I will obtain my grand total. But I can do more than that. Instead of just removing the filter from the country, I get rid of any filter so that I always obtain the grand total, and that produces the number that I want. So I can compute total value by using calculate. Calculate its percentage over X days, and I use remove filters sales. That removes any filter from the sales table and all the tables that have a relationship with sales. Then I compare one with the other and I say result equal. If current value is less than the total value, that means I'm below the average and I want -1. Otherwise, I return +1. Actually, that is not needed. Return result. Let's check that this actually computes a value. Let's say that Germany is below 1149 is less than 14, so I want Germany to be -1 and I want Canada to be +1. We can check that by adding percentage over X days color to the matrix, and you see that we end up having Germany with a -1, that is good, and Canada with a +1, again, that is good. Our measure is computing the correct value. Now I can remove it from here. I don't want the measure. Actually, I want to use it to format the background. So we do conditional formatting of the background color. We want to use a set of rules that is based on percentage over X days color. If the value is equal 1 as a number, then we use this color, because +1 means good. And then if the number is equal -1, that means bad, and we color it with something that resembles red. And clicking on OK, we have our result. Now, this is the dashboard that we created right now, and this other one is the dashboard that we had as a goal. You see that we obtain the same result. The numbers are correct. It is computing the percentage, and everything is working the right way. So, as you have seen, what we did was combining different functions, different simple functions in a single calculation in order to obtain quite a complex dashboard. There were no DAX function able to compute the percentage of orders over time or the percentage of orders with a given number of delivery days. But by combining DAX expression, we have been able to build quite a complex calculation. Still, as I anticipated at the beginning, this code has a small glitch, and understanding how to fix the glitch requires a bit more knowledge that I have been able to provide you in such a short video, because you need to understand a lot more about the filter context and how the filter context is changed by the calculate function. Let me show you first where the problem is, then we will see how to solve that small problem, and finally we'll draw the real conclusion of the video. Let's say that I'm happy, this report works fine, and my users start to use it. For example, a user might start using it and add a slicer. A slicer, for example, over the product brand. I use it as a slicer. Okay, maybe use a larger font. Here under values we use, let's say, 15 points. We can also exaggerate and go for 20. So when the user clicks on a datum, you see that the numbers change, only taking into account orders that contain a datum. But the thing is, look at Northwind Traders. If I look at Northwind Traders, Germany and Italy, they are both colored in red, even though the total is 971%. So they are both above the total, but still my measure is coloring them the wrong way. Therefore, there is a glitch somewhere in my code. I'm not computing the values correctly, and I need to fix that. I need to find where the problem is. And it turns out that solving the problem is actually extremely simple, but you need to know where to search and how to understand where the problem is. Specifically, in my percentage over X day, this is the calculation that I computed, knowing the percentage X days color. Okay, what I need to do is fix the problem. And to fix the problem, I need to get rid of this remove filter sales. Remove filters specifically is removing any filter from the sales. Depending on what I want to obtain, I need to change that remove filter to a different version. I might need to use all except, I might need to use remove filters and values. I might need to use all selected, which in this very special case is likely to be the best option. So look what happens if I just replace remove filters with all selected. That simple change will fix the problem of Germany and Italy and make the entire coloring right. I just hit enter, and now you see that the coloring happens the right way. As it often happens with DAX, small changes, they actually change a lot about how the code is being computed. Now, through examples, I cannot explain the details of what all selected does, or all the details about calculate, or make you understand the theory. The entire point of the video was to show you first that you do not need to know a lot of DAX functions to build gorgeous calculations. You need to know how to use the basic DAX function and combine them together into a single calculation. Combining functions is much more powerful than just using predefined functions. Then, of course, you can use predefined functions if you have them. But if not, then you have the power of building your own calculation by yourself. But then, in order to combine those functions, what you need are two ingredients. First of all, you need to understand theory, because every small change to your formula might have a strong impact on the final result, and you need to understand that. Otherwise, you'll write code that has glitches, as we have seen during the demo. Moreover, you also need practice. The skills of combining simple functions in complex calculation comes with practice. That is why in the training that I deliver, I always teach theory first and practice later. Some theory and a lot of practice, because to me, this is the right way of learning DAX. If you just look at simple examples and you think that you are actually learning DAX, I'm sorry, but this is not what is happening. Worse, you might have the feeling that you are learning, but you're not learning it right. You're not following the best path that makes the best usage of your time in learning this new language. I do hope that you liked this video and that you appreciated how complex calculation can be actually solved with a small amount of knowledge. All what you need to know is the row context, the filter context. These are the basics. And we do have context transition, expanded tables, a lot more theory. But a solid foundation on the row context and the filter context is already enough to build a lot of calculations and build cool reports that will work all the time. If you want to learn them the right way, well, go to sqlbi.com and start right now attending the Introducing DAX training. It is free and it provides you with the foundation needed in order to write calculation like the one we have done so far. If you want more, then we do have the Mastering DAX training. That will go much deeper and teach you all the details, all the theoretical and practical details. It also has exercises and all what is needed to become a DAX guru. And after that, I hope that you will be with me in saying, enjoy DAX.